So before we start looking at some Boolean identities, let's just be sure that you're happy with and or operations. If we've got our two inputs here, A and B, the output is 1 if both A is 1 and B is 1. So right here, that will be 1. In all other cases, the output is going to be 0. For OR, the output is 1 if either A is 1 or B is 1. So these will be 1, and so it will be 0 there. Notice how these are written. AND is A dot B, and OR is written A plus B. Now let's have a look at a few that you might come across. So if over here we start off with A and A, so let's put our inputs in. So we have A here. Now you might think we've got to go through this table with all 4 combinations for 2 inputs, but if what we're looking at is A and A, we've also got A on this side. So if A is 0, A can't at the same time be 1, so we're not going to look at that one. And if A is 1, A can't at the same time be 0, so we're not going to look at that one. So our output, A and A, if A is 0, then 0 and 0 gives an output of 0. If A is 1, 1 and 1 gives an output of 1. If you have a look here, what does A and A equal? The output is exactly the same as the input. So in this one, A and A equals A. If A happens to be 0, A and A is equal to 0. And if A happens to be equal to 1, A and A will also equal 1. Next, let's try A and not A. So let's write that, A and not A. So if this is A, this is not A. So if A is 0, not A is 1. And similar to over here, there's only a limited combination that we can have. If A is 1, not A has to be 0. So 0 and, let's write our output here, A and not A. 0 and 1 is 0. 1 and 0 is also 0. So A and not A will always equal 0. Next then, let's have a look at 1 or A, and the other one we'll have a look at is 0 or A. So we'll put the headings in, 1A, 1 or A, and over here 0, A, 0 or A. So 1 is always going to be there. A could take the value of 0 or 1. So this is all. 1 or 0 is 1. 1 or 1 is also 1. So 1 or A will always equal 1. Doesn't matter what A is. A can be 0 or A can be 1. The output is always going to be 1. On this one, our input is in one of these is always going to be 0. On the other one, A can take the value of 0 or 1. So 0 or 0 gives an output of 0. 0 or 1 gives an output of 1. So if we have a look and see what the output is, the output, if you look at spot the pattern, the output there is always equal to what the input on A is. So 0 or A will equal A. Right, next to then, let's have a look at A or A or A, and A or not A. So here we go again, A or A, not A or not A. So values can only be 0 and 1. So if A or A in this case is 0, 0 or 0 is 0, 1 or 1 is 1. So if you have a look at that, whatever A happens to be, A or A is. On this one, if our inputs are 0 and 1, not A has to be 1 and 0. So in this case, 0 or 1 is 1, 1 or 0 is also 1, so it doesn't matter what A or not A is 1. Hope you're seeing the pattern that we've got here in terms of writing out our simple truth table, filling it in with the possible values, and then spotting the pattern, spotting how the output relates to the input. In some cases it relates to what A is, and in other cases it actually doesn't. It might just be 0 or 1 regardless of what A is. Right, let's do 2 more in this video. 0 or A and 1 and A. Sorry, I think I said on this one, or it's and, of course, 0 and A. So let's put these in. 0 and A, 0 and A, 1 and an A, 1 and A. Right, so over here, our input on this one is always going to be 0, and so A can take the values of 0 or 1. 0 and 0 is 0, 0 and 1 is also 0. So 0 and A is always going to equal 0. 1 and A, let's have a look. Input on this one is always going to be 1. Here, A can take the values of 0 or 1. 1 and 0 is again 0. 1 and 1 is 1. So here, 1 and A, if you have a look, where's the pattern? The output happens to be the same as whatever A is. So 1 and A will equal A.